Okay, earning interest. Some formulas to start us off. We have interest is equal to the principal, which is the amount of money that you start off with, times the rate, which we always put in as a decimal, times the time, in this case years. Okay, that's how you calculate the interest. That's a simple interest formula. Now, compound interest. So, for example, let's say that interest is accumulating each month or each week or even continuously. We would want to use one of these two formulas. Here's one. Okay, and then here's another one. So this one is compounded in a specific time period. And this one is continuous. So anytime you have the E, you know that this is a compounded continuously. Okay? So how are these new formulas related to the exponential function y equals a times b to the x? Well, a is going to represent our starting amount. Starting amount. How much did we begin with? That's our principal. Okay? B is going to be our base. In this case, it's E. In this case, it's this number. And it has to do with whether or not our money is increasing or decreasing. Usually and hopefully we're increasing. That's why it's 1 plus the rate divided by the number of times it's compounded. So if it's compounded monthly, this would be 12. And so we would have this as an appreciation or an increase. Okay? And then we have our exponent, which again is dealing with our time. Okay? So let's take a look at what each of these represent. Okay, here's a little graphic to help us fill in that information. Here we have our amount. We have our principal. This is our beginning amount. And the A is going to be our ending amount. What is the result? We have our rate of interest. Rate of interest, remember, is going to go in as a decimal. Okay, N, that's going to be the number of times per year interest is compounded. We'll talk about that again in a little bit. T is time in years. How many years will our money be accumulating? And then E, that's going to be our, let's move over here real quick to our calculator. And it's not showing up. Just one moment. Okay, so when we're using E, we're going to use over here e to the x power when we're using this formula, e to the x power. Remember that the value of E, second divide, the value of E is 2.718281828. But we don't need to plug that number in when we're using this formula. We just press second ln and then we fill in the information from there. Okay? Okay, so hopefully you've got this copied down from that graphic. We'll go ahead and write this number in. 1828 approximately. Okay, what will the value of n be for each compounding time period? Let's see if you can figure out what these numbers are on your own. All right, compound interest formula. Okay, so which formula are we going to use? Let's read it. You put $2,000 in the bank. It earns 5.4% interest, compounded monthly. Okay, so this is not continuous, so we're going to use this formula right here. So let's plug the numbers in. So it says write an equation to tell you how much money you have in your account for any number of years. So A equals our principal times 1 plus the rate. Okay, we need to change this to a decimal. So 0.054, move the decimal 2 places to the left, over monthly. Hopefully you came up with the number 12 on the previous page. Okay, and then let's write this in real quick. So monthly, so 12 says for any number of years, so T. There's our formula. Okay, how much money will be in your account after 6 years? So we just plug in 6 in for T. I'm going to go ahead and divide that. Let's see what that comes out to be. Let's do that real quick here. We have 0.054 divided by 12. And let's go ahead and add that 1 on. So 1.0045. Raised to the 12 times 6. So remember, we're simplifying this. So always start with parentheses. So we're going to have 1.0045, parentheses first. Then we apply the exponent. So 1.0045 raised to the 12 times 6, that's 72. Okay, and then we apply multiplication next. Times 2,000. So after 6 years, compounded monthly, we should have $2,763.29. Don't forget dollars and cents. Oops. And don't forget dollars and cents, we round to the nearest hundredth. It says, when will you have 5,000? So 5,000 is what we want as a result. Okay, so we're solving this for t. We want to find out when. Okay, so now we're solving. So remember, here we were simplifying. So we were working PEMDAS forwards. So now here we are solving. So we want to work PEMDAS backwards. So undoing any adding and subtracting, none. Any multiplying and dividing, yes. This is multiplication. So we get 2.5 equals okay. Then we undo any exponents. All right. Well, in order to do this now, we have to use logarithms. So we're going to start off by taking the log of both sides. And I'm going to go ahead and bring that exponent down front. Okay, so I took the log of both sides and I brought the exponent using the power property down front. Then we're solving for t, so I'm going to divide both sides by log Okay, so we're going to have 12t equals, and let's see what we get here. The log of 2.5 divided by the log of the other number. Okay, now what you want to do here is you want to just divide by 12. Don't use the approximate. Try to use the long number. So it's going to take 17 years to get that much money. Okay? All right, compounded continuously. So I always remember this by PERT. P-E raised to the R-T. PERT. Pertinent. It's a very pertinent formula. Yes, indeed. Especially if you're compounding continuously. Feel very mighty British there for a moment. I'm sure you liked that, James, didn't you? You put $500 in the bank. There's our principal. Here's our rate. It's compounded continuously, so we use this formula. Let's write the equation. PERT. Oh, I messed up. Oh my goodness, I messed up. Oh well. P goes there, and our amount that we end up with goes here. Sorry about that. Plugging in our numbers, 500 goes in for P. Remember, we need a rate, and you change the decimal, move it over 2 places. And that's going to be times T. All right. Ooh, got 2.5 minutes. Let's go. Plug 5 in. We're going to have 500. E. How much money after 5 years? Plug 5 in for T. Easy peasy. 500. Second ln. And it's times 5. Make sure I did that right. Yes. Compounded continuously, we end up with $588.22. Okay? Now, let's use some common sense. When you get your answer, look at how much you started with. Does it make sense? Yes. Move on. When will you have 2,000? So here we go. When will we have 2,000? Future, future, future amount. We're looking for, got the same interest rate, looking for the time. Zeros, zeros, 4. Okay, 1 minute to go. All right, go Spurs, go. Now, since I'm doing E, I'm going to go ahead, instead of doing the log of both sides, I'm going to do the natural log of both sides. And I'm going to bring my exponent down front. What's cool about taking the natural log of E is this. Natural log E. Check out what happens. Wow. 1. They cancel each other out. Natural log of E is 1. Divide both sides by 0.0325. So time, do we have time? 25 seconds. Natural log 4 divided by 42 years. 42 years. Any brainies out there that can tell me how many months that is? How many months?